Okay, so that other stuff, I got cut off there for a second there. So remember, if the temperatures for the lighter colored rocks or the felsic materials are around 700, 800, and the temperatures is not high enough to melt the black stuff, that felsic material will stay in the solution. And so what ends up happening is magmas generally, as they melt other rocks, the magma slowly becomes more felsic, leaving behind the mafic stuff. Or, if you go back one, when they cool, the mafic stuff falls out first, therefore the actual magma becomes more felsic. So generally overall, the magma tends to become more felsic over time if it's allowed to cool. If it cools off too fast, it's just going to be mafic. But if it cools off slowly, you can slowly have that separation, or what we call differentiation, of the different minerals. Okay? And that happens when you partially melt rocks, or if you have a melt that actually is cooling off. They both become more felsic. Okay, so that's the start of how melts actually occur, or how we get melts. But let's talk about how we actually classify these. We've talked about felsic materials, we've talked about mafic materials, but let's talk about how the classification or the look of these rocks can help us to understand their history. Now, if you look at this, you can see these are three types of texture, and I'll show you some more types of texture in just a second. Because we classify igneous rocks based off of their texture and their composition. Now, remember, the composition really can be understood by the color of the rock. The darker it is, usually the more mafic it is. The lighter it is, the more felsic it is. So out of these three rocks, this one right here is probably the most felsic of the three. This one right here, what we call obsidian, is probably the most mafic of the three. And this is more of an intermediate of those. We still consider this a felsic rock because there's lots of still felsic materials, but this is more felsic. Sorry, this is less felsic than this one, right? Because this one has lighter colors than this one really. Okay, so the point comes that, but the texture of these is different too. If you'll notice the texture on this one, there's actually individual mineral grains. And it looks a lot like the one that I have here in my hand. We have individual mineral grains here. This is what often we call a granite, right? And these granites, you can see the individual grains with your naked eye. And so those rocks, you can really tell that have actually been cooled underground, where they've had time to cool off. Okay, whereas this one is what we call a fragmental piece. This is an example of a fragmental piece that I have here. There's actually small little fragments of pumice or things that are flown out of a volcano, an ash cloud, and then fallen back down. Same thing for this one right here, which was the deposit of ash, or what we call tuff. And this rock here is basically the same kind of rock that you have here. This is what it would look like in the underneath a microscope, right? Each one of these. And these are individual small pieces of ash that came out of a volcano. So this is what we call a fragmental or a pyroclastic piece. Pyroclast meaning particle of fire, right? Okay. And the last one here is, I don't have my sample here with me right now, but is obsidian, which means that it cooled off so fast that it didn't get into its crystalline form. Okay. So these are three types of textures. Let me show you some more. Okay. So you have the glassy texture here, which we call obsidian, and this is one that actually cooled off so fast that it couldn't get into its crystalline structure, and so we call it a glass. It's in a volcanic glass. This one tends to be very mafic rich because of the darker colors, right? And then you have your pyroclast, which is your particles, okay, that you see here. They're usually volcanic in nature. So these are all what we call extrusive textures, things that come out when they come out of volcanoes usually. Okay, pyroclast is ash, blocks of rock coming out, lava bombs. We'll go to some of these in a bit. Then the glassy, and then we have what we call vesicular. Vesicular ones, actually, you can see this in this one as well. There's lots of air pockets in this one here. And what's happening here is the magma flows, or sorry, the lava flows, the gases are trying to escape, and those escaped gases come out of all these different holes over time and form what we call this vesicular pattern to it. Okay? So those are all some special types of texture. Now these other types of texture have to do with how fast the actual magma or the lava cool off. If it's on the surface and the actual particles are really small, like I showed you in, here's one right here, it's hard to see the individual grains in this one. I know it's hard to see in the video, but the individual grains in this are very small. You kind of see them, but they're so small, so we'd call this an extrusive rock. It cooled on the outside, or some people sometimes call it a volcanic rock, right? And so we call this an aphanitic texture. So the grains are so small that it's hard to see with the naked eye. Whereas this one that I showed you just a minute ago, you can very easily see it with the naked eye, each of the individual grains. And so we would call that actually a phaneritic texture, which is basically cooled off underground, because the grains were so big that they could actually have time to cool off. Each mineral grain can cool off to make a larger grain. So here's an example. This is one that actually was cut and sliced, and you can see the individual grains inside of that, right? So this would be what we call a phaneritic texture. You can see this one tends to be pretty dark, so it's very mafic rich, but it's a phaneritic texture nonetheless. Okay, and this one right here is what we call a porphyritic phaneritic. Now notice in this one, there's some of the grains are really big, and the rest of them are relatively the same size. They're small. So there's two cooling histories here. Now, it could mean two things. It could mean that either it cooled off in two different rounds. First off, it cooled slowly, so you get these big minerals, right? But then it cooled off really quickly to form quicker to form the smaller ones. So you can have this, what we call this porphyritic phaneritic texture, where the ground mass, the stuff in the back, you can still see the individual grains, so we call that phaneritic. But up here, you can see there's porphyritic ones on this one too, but the ground mass behind it is so small that we can't see the individual grains. So we'd call this an aphanitic porphyritic. So porphyries are ones where you can see the bigger grains. There's a larger pore in it. So the one that I actually was showing you earlier, this one right here, you actually will notice there's some big grains here. Where is it? Over there. Okay. But there's also small ones too. The small ones is what we'd call the phaneritic texture, and the big one here is the porphyritic texture. So this is a porphyritic phaneritic, which tells us that this rock actually cooled off in two cycles, or there was excess water in it, so one mineral actually will cool off, will actually cool faster than another one. Remember, water has interesting effect on some minerals. It will cool them off faster than others. So anyways, so it's that porphyritic texture can tell us that this had an interesting two-phase cooling history, or had excess water in it. Okay, so notice that some of these textures have a history behind it. So if we find a rock that has pyroclastic textures to it, we know it came out of the volcano. If we have one that has vesicular textures, so we know that it has a lot of gas in it that was coming out of probably a lava flow. If it has this glassy texture to it, it probably cool off so fast. So in a locality like maybe in cool off in water, or maybe it rained right after or whatever, where it's cool off so fast that it couldn't get into its crystalline structure to form into a glass. Okay, so these have distinct properties to them that will help us understand what the history of the rock was in the past. Now these ones do as well. If it cooled off really fast, that means it actually, we can't see the grains, it probably cooled at the surface or near the surface, so we call them extrusive or volcanic rocks. If it has two different crystal sizes, they either once again had too much water in it, or they actually cool off in two actual phases. We won't, that we don't know, but at least we can narrow it down, right? Now if we had all the grains, the ground mass and that we can see behind it are the same, and we can see them, we'd call that a phaneritic intrusive rock, which means that it cooled off slower underground. Sometimes we call these plutonic rocks, if you remember. Now, if you had two different sizes, once again, you have the background, or what we call the ground mass, is we would know it's an intrusive rock, or so we call it phaneritic. But the other ones are bigger than those, so we know it's a two-phase cooling, or there's too much water, and so it actually cool off into two different grains. Okay, so these textures can tell us a lot about the history of a rock. And if we get a combination of these textures in a region, they'll tell us a lot about what happened in that region. It's kind of like we were talking about before, when we were talking about our geological science investigations, or in the criminal justice world, we call it a CSI, right? Crime scene investigation. When we're talking about geological scene investigation, right? Okay, so I wanted to just show you some more examples of this. Here's that glassy texture. If we have some that are so glassy, we have to call that pumice. And some of you ladies use this sometimes to scrape the dead skin off your elbows or your knees and stuff like that, because it's a good abrasive, right? And then there's this glass, and because all it is basically volcanic glass. So pumice actually forms. It's kind of like the froth on your root beer or your root beer float. or if you drink, I don't drink, but if some people from you guys might, the beer, the froth on top of your beer, right? It's all that, the bubbles coming out of the top, out of the gas or the liquid, forming these little bubbles on the top. And when these bubbles actually cool off, they can become into what we call pumice, right? And it's really light. Pumice is actually so light that it can actually float on water. Now, obsidian cooled off so fast that it actually couldn't get into this crystalline structure, and so it has this nice glassy texture to it. Okay, and the last one we want to show you is those pyroclastics. These pyroclastics, these are the ones that have fragments inside of them. They can have big fragments like this, which we call volcanic breccia. Okay, or we have small fragments like this one here, like the one I showed you just a minute ago. There it is in front of me. Okay, which has small fragments, which we call a tuff, which is ash-sized fragments. Or you can have ones like this, which is still a tuff, but it has lots of smaller, bigger pieces in it. So it has that. It could potentially be a breccia. The small ones, but most people would still consider this a tuff. The breccias usually have a lot bigger class inside of them. Okay, and I have an example of one somewhere, but I don't have it with me right now. Okay, so when you mix these two together, the composition and the texture, you can get a good understanding of both the composition of the rock and the cooling history. So for example, these are all extrusive rocks. Remember, the ground mass behind them are small enough that they actually can't see them. So if it's light in color, we call it a felsic rock, and if it's extrusive, we usually call it a rhyolite. So a good example of a rhyolite might be this one right here, kind of this cool, this lighter color, and the mineral grains tend to be small enough that you can't see with the naked eye, right? An intermediate one, I don't have one intermediate with me right now, but an intermediate one might be andesite, and then your darker one here would be your basalt. Now there is such things as what we call a really dark one, which we call ultramafic, but I don't have an example of those. Those are very, very rare because they would be very characteristic of our mantle beneath us. Okay. Now if a cooled, and often that mantle doesn't come on the surface to flow out like a lava flow, right? So it's very, very rare here. Okay. Whereas the one at the bottom here is what we call our intrusive rocks, going from felsic to ultramafic. The felsic one, this is a good example of the felsic one, is this one right here. This is the same granite that comes from Mount Rushmore. And you can see that it has dark minerals in it, still has those mafic minerals in it, but it also has the felsic minerals in it. And so, so this would be called granite. Now, if you got a little bit darker, which I don't have a great example of an intermediate one, but lots of times we call them like salt and pepper, so they look half black, half white, and these are often what we call diorites. And if you go really dark, you might get into what we call a gabbro. Now, the best one gabbro I have here is this guy here. You can see individual crystals in this quite well. If you look at it, the shiny places there are crystals. But this one still has a little bit more felsic material in it. So it's not a pure gabbro, but it's some gabbros are almost completely black. And sometimes you can see it on countertops. Some people would call them black granites or dark granites, and they're actually gabbros. And they cool underground but have a mafic composition. The last one there is what we call peridotite, which happens to have my favorite mineral in it, if you guys remember, which is peridot. And peridot is the birth gemstone for somebody born in August. And so the green stone there. And those aren't very stable on the surface, and so but they're very, very dense. This one here actually has a little bit of peridot in it. It's right there at the top, right there. Oops, there. Okay, you see it. I kind of didn't point at it very well. But anyways, it has some peridot in it, and that peridot is actually material from deep down in the mantle. So when it cools off and comes to the surface, it's rare. But this one actually has a sample of it. I have some better samples of it over here somewhere. But the point comes is you can see the big grains and it cooled above ground, right? Okay. So those are how igneous rocks are classified. Now, in your assignment this week, your discussion, you're going to be doing something like this, where you're going to look at these different rocks, you're going to look at their textures and their compositions, and be able to try to identify the type of rock it is. Is it rhyolite, granite, andesite, whatever, down the line, right? Or you can have the other ones, which are the special ones, which is like the volcanic breccias or things like this, okay? And then you're going to tell us a little bit of the history of it. Is it extrusive? Is it intrusive? And so forth. That's going to be your discussion this week.